Welcome everyone to Lesson 1.7 done quick. Lesson 1.7 is all about selecting procedures for limits, which is a very, very fancy way of saying we're going to do some more algebraic manipulation of limits, specifically some more challenging ones, like the two you see in front of you. So we're going to be talking about these limits in two different categories. One where we have radicals, and another where we have fractions within fractions. So let's talk about the radical one first. If I were to directly substitute in 1 here, I would get the square root of 3 minus the square root of 3 over 1 minus 1. That might look a little familiar to you because that'll be 0 over 0, which is the indeterminate form. Again, a clear indicator that something can be done with this. But what? So I want us to recall our pre-calculus days. And if you didn't have me, then think of whoever you did have for pre-calculus. They probably taught you about complex conjugates, which is where you had a plus bi, and its conjugate was a minus bi. The cool thing about conjugates is when you multiply them together, they cancel out the middle term. If I multiply these, it is essentially just a squared minus b squared times I squared, which just essentially makes a squared plus b squared. No more imaginary numbers. We can use something similar here to get rid of some of these square roots. We can rationalize these fractions a little bit. So, instead of using a plus bi and a minus bi, we can use the conjugates a plus b and a minus b, because when I multiply these two together, I get the difference of squares. I get a squared minus b squared. So let's use something similar here, and let's just see what happens. So I'm going to multiply the numerator and denominator by the same number so I can keep it equivalent. I'm going to multiply by x plus 2 plus the square root of 3 over x plus 2 plus the square root of 3. And from this, we can surmise that the middle term is going to cancel out, so all I really need to do is multiply the first term by the first term and the second term by the second term, and those roots cancel out, which is kind of nice. So we get x plus 2 from multiplying this root by this root, and then we get minus, because we have a negative times a positive, root 3 times root 3, which is just 3. Then we get that over, and this is quite ugly. Let's not make it any prettier, because I don't think it's going to really become any prettier. Plus, we're going to see some really interesting interaction take place. So we have this. This is great. It's super great. It looks wonderful, doesn't it? So much stuff going on. Let's clean up the top. We have plus 2 and a minus 3. Plus 2 minus 3 is minus 1. So the top simplifies to be x minus 1. Well, I see something interesting, don't you? We can cancel out our problem. And so we have 1 over the square root, and I'm going to evaluate it now, which is the square root of 3 plus the square root of 3, which is equal to 1 over 2 square root of 3. If you want to rationalize that, you can. You would get root 3 over 6. And that is the answer. That's really cool, and it's kind of awesome that that happens. It's a lot of algebra, and some people are prone to making mistakes with it. But does it work all the time? And the answer is not always. You have to be very careful. If you can evaluate it and you get the indeterminate form, then that's clear to you that something can be done. If you don't, things might not cancel as nicely as these do. So please be careful. I would always check for the indeterminate form first, because if you don't get it, then this probably won't help you, and that's a lot of time for something that's not going to help you. The second part is fractions within fractions. If I plug in 0 again, I get 0 in the numerator pretty easily, but then I get 1/2 minus 1/2, which again is 0 over 0, indeterminate. So, clear indication, something can be done, and what we can do is we can try to simplify these fractions. Usually, if I divide something by a fraction, I can multiply by its reciprocal. But here, I have two fractions in my denominator. I have to combine them first. Well, how do I subtract fractions? Well, to subtract fractions, you need common denominators. So, least common denominator for, least common multiple for this one is x plus 2. Least common multiple for this one is 2. So I'm going to multiply the first one by 2 over 2. I'm going to multiply the second by x plus 2 over x plus 2. And what happens there? Well, that x in the numerator just stays there, and we're going to have 2 minus x plus 2 over, and the denominator should just be 2 times x plus 2. Well, does anything happen here? Well, we do have some things happening here. We have this minus here. So let's go ahead and distribute this. And then we have negative x here, and we have 2 take away 2. So this will clean up to be x over negative x over 2x plus 4. Keep in mind that the original fraction bar was with this x. So in terms of the overall fraction, this fraction here is the denominator. So when we multiply by the reciprocal, we are flipping this. So we have this x to begin with here, and we're going to multiply that by the reciprocal of this fraction, 2x plus 4 over negative x. What happens? Well, this x and this x will cancel, and the negative will just get multiplied in. So we have negative 2x minus 4, and if we evaluate that at 0, we don't get any problems, we just get negative 4. So again, this one had the indeterminate form, very clear that something would get fixed if we manipulate it. If you do not get the indeterminate form, you may be doing a whole lot of work for no solution. So please double check that. That is lesson 1.7 done quick. These are complicated limits, especially if your algebra skills are not top-notch. So practice makes perfect. Keep practicing, don't stop, and don't get discouraged. Ask for help if you need it, and good luck. I'll see you in the next video.